Hi everyone, it's Math with AUB. Let's get along for the preparation of SAT and GRE mathematics. Without wasting time, as usual, question number in our series, we have already done 5 questions. It's question number 6. Lump sum question number 6, video number 2. In 1980, Elan was 8 times as old as Adam. In 1980, Elan was 8 times as old as Adam. And Judy was 3 times as old as Adam. Alan is 20 years older than Judy. And what is the relation and what is the age of the Adam in 1988? As usual, these are two columns. Whether column 1 is greater than column 2 or 12 is greater than column 1, both columns are equal or no conclusion can be drawn. Let us translate this problem into mathematical expression as Elaine was 8 times as old as Adam. Elaine was 8 times as old as Adam. Let me take E for Elaine. 8 times as old as Adam. It's our equation number 1. Elaine was 8 times as old as Adam. Elaine was 8 times as old as Adam. I have written E is equal to 8 times A, equation 1. And Judy was 3 times as old as Adam. And Judy was 3 times as old as Adam. Judy was as old, 3 times as old as Adam. This is our equation number 2. Judy was 3 times as old as Adam. Equation number 2. And the final and the last line, Elaine is 20 years older than Judy. Elaine is 20 years older than Judy. Elaine is 20 years older than Judy. Means Elaine's age is 20 plus the age of the Judy. Elaine's age is 20 plus the age of Judy. That's our equation number 3. That is all happening in 1980. It is all happening in 1980. We are asked to find Adam's age in 1988. Adam's age in 1988. Let me shed some light again on this model that we have translated sentences into mathematical expressions. Elaine was 8 times as old as Adam, and Judy is 3 times as old as Adam, and Elaine is 20 years older than Judy. Elaine is 20 years older than Judy. We have to tell the age of Adam in 1988. 1988. It is all happening in 1980. 1980. Mathematically, I can replace Judy by 3a. Plug in this value of J in this equation. So I have E is equal to 20 plus J. Instead of J, I can plug in 3a. So we have E is equal to 20 plus 3a. 20 plus 3a, equation 1. And similarly, this is E, this is 3a. E is equal to 20 plus 3a. I have two possibilities. Whether I switch over instead of E, 8a. Instead of E, I can switch over 8a, or instead of A, I can write E over it. Whatever path you want to take, just take. Translate this equation into any single unknown, whether it is Elaine, whether it is Adam, whether it is Judy. It's safe to introduce 8a instead of E. 8a instead of E, we have 8a is equal to 20 plus 3a. Solve for a, shift a here, it will become 8a minus 3a is equal to 20. The difference of 8a and 3a is 5a, no doubt. 5a is equal to 20, dividing by 4, we have Adam's age is, dividing by 5. In order to get a We have Adam is equal to 4 years. Adam is 4 years old in 1980. In 1980. But we are asked to find Adam's age in 1988. Adam in 1988. So Adam's age will be 4 plus 8. In 1980, Adam's age was 4 years. In 1980, Adam's age was 4 years. We are asked to find its age in 1988. 1988. We have added 8 in 4. 4 plus 8, 12 years. So it is very safe to conclude that we put the symbol is equal to between column and A. The relation exists between column A and B. They are equal. The relation exists between column A and column B. They are equal. They are equal. They are equal. Moving towards next question, we have moving towards next question. We have A, B, C, D. It's a square. A, B, C, D. It's a square. Having area 100 square units. Having area 100 square units, and the triangle DEC. And the triangle DEC having area 10 square units. Having area 10 square units. Furthermore, let me repeat, ABCD is a square with area 100 square units. With area 100 square units. And furthermore, the triangle DEC having area 10 unit square. 10 unit square. Furthermore, EC is equal to ED. These two sides are congruent. These two sides are congruent. What is the distance from A to E? We are interested in the distance from A to E. From A to E. We are interested in this. We are interested in this. Let's utilize some information that we have given. We have given a square. We have given a square having area 100 square units. 100 square units. Area square is given by side square is equal to 100. Taking a square root both sides, we have side is equal to 10 square, 10 units, 10 units. So each side is of 10 units, 10, 10, 10. Because it's a square, in square all sides are equal. We have utilized the fact area of the square is 100 square units. Area of a square is 100 square units. Side square, or some people write x square is equal to 100. So side is equal to, taking square root, side is equal to 10. Side is equal to 10. Side is equal to 10. So side is 10. So this DC is also 10. This DC is also 10. This DC is also 10. Furthermore, we have given the triangle. This is the C. This is E. From this, the dimension of DC, the length of DC is given to us. The length of DC is given to us. Furthermore, DE and EC, they are equal. DE and EC, they are equal, having area 10 square units. Having area 10 square units. If I draw a perpendicular bisector, then it is 90, it is 90. Having 5 units length, it's 5. It is perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Let me name it F. Let me name it F. So, area of any triangle, area of this triangle is equal to area of this triangle. They are both congruent triangles. They are both congruent triangles because this side is common, this side is common, belongs to DEF as well as EFC. This side is common. Furthermore, this DF is 5, this DF is 5 as well as FC is 5. DF is 5, FC is 5. Furthermore, it is given to us DE equal and EC equal. By the virtue side, both triangles are congruent, side. Taking any one portion from this, let me take D F and E. It's a right triangle, it's a right triangle, it's a right triangle. We can safely conclude that we can find its area as area of this triangle is given by 1 upon 2 base into height, base times height, base times height. What is base? No doubt it is 5. It is DC total 10. F is the bisector midpoint of D and C, midpoint of D and C. So it is 5. Height we are interested in. We are interested in height means it's our EF. EF we are interested in to find. Further, total area is 10 square units. Total area of this triangle DEC is 10 square units. Area of DEC is 10 square units, but this line has divided the triangle into two sub-triangles with equal area 10 divided by 2 having this area of 5, this one as well as area of 5. So area of this any single triangle is 5 square units. It's also 5 square units. Plugging in here 5, solving for EF 2 times 5 divided by 5 is equal to EF. 5 cancel. EF is equal to 2 units. EF is equal to 2 units. Now our game begins. This is our 2 units. If I complete this one, this is also 10. This is also 10. And this is 5. DC is 5. AB is 5. This is 5. This is also 5. Let me slash out this portion that we are interested in. Here it is 2, it is 10, 2 plus 10, it is our 12, 2 plus 10, 12, it is our 5, and we are interested in A to E, A to E, and let me name it P, AP. Applying Pythagoras theorem, this is perpendicular, this is perpendicular, this is base, this is perpendicular, this is base, and our required AE is hypotenuse. Our required AE is hypotenuse. Applying Pythagoras theorem, I have h square is equal to base square plus perpendicular square. AE, we are interested in to find its length, is our hypotenuse, base AP, and perpendicular EP. Hypotenuse we are interested in, base is 5 square, and our perpendicular 2 plus 10, 12 is square. So we have h square is equal to square of 5 is 25, the square of 12 is 144, it is 169. Taking square root of this one, taking square root, so we have hypotenuse is equal to 13. Hypotenuse is equal to 13 units. So our EAE is 13 units. 13 units. 13 units. So our answer is AE. AE. What we have done, we have given the area of this square ABCD 100. Formula for area of square is side square or x square. X square is equal to 100. Taking square root, x is equal to 10. Each side 10. This is also 10. This is 10. This is also 10. Okay. Furthermore, this triangle is given to us having DE and EC are congruent. DE and EC are congruent, having area 10. We have dropped a perpendicular line. We have dropped a perpendicular bisector. EF on DC. It gives us DF 5 square unit 5 units, FC 5 units, DF 5 units, FC 5 units, and we have divided the area by 2 because they are both congruent triangles. Total area 10, 5 here, 5 here. It will area evenly distributed 5. So we have taken this fact 1 upon 2 base into height. Our height is EF. We are interested in, and we have taken not 10, instead 10, 5, because we have taken only one half, either this. Both are congruent, equal. I have taken 5 instead of 10. I have taken 5 because I have taken only one side. half of the triangle, half of the original triangle, half of the original triangle, half of the original triangle. Solving for EF, we have EF is equal to, plug in this EF is 2, this is square having AD 10, DC 10, so this FP also 10. 2 plus 10 it is our perpendicular, 2 plus 10 it is our perpendicular, and bases are 5. We have taken half of the base of the square, its AB is 10, AP is 5. Applying Pythagoras theorem, AE is our hypotenuse that we are interested in. AE is our hypotenuse that we are interested in. Applying Pythagoras theorem, base is square, perpendicular base is 5, perpendicular is 12, 5 square 25, 12 square 144, 25 plus 144, 169, taking the square root. So we have this length AE is equal to 13 square units. Moving towards next question, we have moving towards next question, a good question, a wonderful question. If 3x minus y is equal to 3, what is the value of 8 raised x divided by 2 raised y? It is a famous streak that is running for set examinations. Everybody who is making good use, it is a wonderful question for them. I have made a reel a long way ago, at least 2 years ago. 2 years ago, one of my first reels on that question. If the given part 3x minus y is equal to 3, it is given to us 3 times x and minus y is equal to 3. What is the value of 8 raised x divided by 2 raised y? Let's see how simple this question is. Okay, 8. I can write 8 as 2 raised 3, 2 cube. This is x. 2 raised 3 times x, and this is 2 over y. Power having another power, multiply the powers, it will become 2 raised 3x. 2 raised 3x divided by 2 raised y. 2 raised y. Applying tiny exponent rule, we have, I can write this figure as 2 raised 3x times 2 raised negative y. 2 raised negative y. I have shifted this 2 raised y from denominator to numerator. I have changed the symbol of the power, changed the symbol of the exponent. As bases are same, they are in multiplication, merge their powers, add their powers. Bases are same, they are in multiplication, add the powers. We have, write to 1 times 3x minus y. Now we have this, the value of 3x minus y is equal to 3. Instead of this 3x minus y, plug in the value. We have 2 raised 3, 2 cubed, 2 cubed means 8. 2 cubed means 8. Our answer in that case is 8. What we have done, it is a closed system. Just think within the given parameters. We have given 3x minus y is equal to 3. It is the beauty of your rational, it is the beauty of your document to see this thing here. 8 can be written as 2 cubed times x. It is 2 3x, 2 divided by y. Now it's very simple. Bases are same, they are in division. I have taken this power into numerator, or one can write 2 single time 2 raised 3x minus y directly. But I have shifted 2 raised y in numerator, 2 raised minus y. Bases same, merge the powers, write to 1 time 3x minus y. The value of 3x minus y is given to us, that's 3. The value of 3x minus y is given to us, that's 3. 2 raised 3, 2 cubed. 2 cubed means 8. So our answer in that case is 8. Moving towards next question, we have given that x does not equal to y. And that x minus y raised square is equal to x square minus y square. Which of the following must be true. Which of the following must be true? Number 1, x is equal to 0. Number 2, y is equal to 0. Number 3, x is equal to minus y. These are the possibilities. Which one is true? Mention in the options. Let's see and find out. What is given to us? For the given that we are forbidden to utilize x is equal to y. We are forbidden. Given that x is not equal to y, and that x minus y whole square is equal to x square minus y square. X square minus y square. X does not equal to y, and x minus y whole square is equal to x square minus y square. Open this up. It gives us x square minus 2 times x times y plus y square is equal to x square minus y square. We have opened this perfect square quantity x minus y whole square, square of first quantity, square of first quantity, symbol same, negative, twice, first into second, twice, first into second, plus square of second, right hand side same, shift all the quantities on the left hand side, we have x square minus 2xy plus y square, taking them to the right left hand side, it will become negative x square, positive y square is equal to 0. They are no more. Positive x square, negative x square cancel. They can be merged. Y square plus y square, 2y square. Y square plus y square, 2y square. Y square plus y square, 2y square. Negative 2xy. Y square plus y square, it will become 2y square. 2y square. 2y can be factored out. 2y can be factored out, taking 2y common. What remains here? Minus x and plus y. Minus x plus y. Either or. 2y is equal to 0 gives us y is equal to 0 over 2 means 0. We have y is equal to 0. And from this, negative x plus y is equal to 0. Negative x is equal to negative y. Minus minus cancel. X is equal to y. X is equal to y. We cannot take this. We cannot take this because we are forbidden. We are forbidden to take that value. X does not equal to y. We have the possibility x is equal to y, but we are forbidden not to take x is equal to y. So, or only the lone option is y is equal to 0 is the correct possibility here. Y is equal to 0. 2. B is our option. Let me shed some light why x does not equal to y to be taken in that question. However, we have forbidden. Just utilize this y is equal to 0, it is our option, and we have done our work. But mathematically, you can think in that direction why we have been forbidden to take x does not equal to y. Let's see and find out what is the logic or rocket science behind this. The rocket science, simple logic behind this. Okay. These two expressions can be simplified as x minus y times x minus y. Difference of two square situation, x positive y, x minus y. We can divide, either take x minus y here or dividing by x minus y. Dividing by x minus y, we have cancelled out. We have x minus y is equal to x plus y. Solve, shift them on one side, x minus y minus x minus y is equal to 0. Cancelled out. Minus 2y is equal to 0. We have y is equal to 0 minus 2. That's 0. That's 0. Now look at this. We have divided by the quantity x minus y. We have divided by the quantity x minus y. And we are familiar that in mathematics, in denominator, a rational expression, x denominator doesn't vanish. Denominator never 0. Denominator is never going to be 0. Denominator is never going to be 0. Here x is equal to y. That's why we have been forbidden. If we take x is equal to y, if we take x is equal to y, put x is equal to y or y is equal to x, then this is indeterminate form, undefined form, indeterminate form, undefined form. That's why it is a question in that question not to take x is equal to y, not to take x is equal to y. If you are going to take x is equal to y, then you are not in a position to divide by x minus y. Then you are not in a position to divide by x minus y. Why? Because the denominator vanishes. The denominator becomes 0. The denominator becomes 0 at x is equal to y. That is the simple logic or science behind not taking x is equal to y. Okay, moving to our next question. Next question we have given a triangle, that is our angle A degrees, B degrees, that is D degrees, and it is C degrees. Now we have to hunt what is the relation between A, B and C. A, B and C. Look at this, a tiny fact to be utilized in geometry. This is known as exterior angle of a triangle. C is exterior angle of a triangle. Exterior angle of a triangle. Exterior angle of a triangle. And D and C, angle D and C are known as adjacent angles. Are adjacent angles. C is exterior angle of this triangle. C and D, they are adjacent angles because they share this common arm. They share this common arm, or one can say side. One can say side. If I name them A, B, C, D, read the angle C. Angle C is A, B, C. This is our angle C. And when I read angle D, it is CBD. 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 It's equal to D. It's equal to D. It's equal to D. They share CB as common. CB as common here as well as here, as well as here. That is a common vertex. Common vertex. Common vertex. Common or common side or common arm. Okay. There's a little fact in geometry. This exterior angle is equal to the sum of the non-adjacent interior angles. This exterior angle is equal to the sum of the non-adjacent interior angles of a triangle. This exterior angle is equal to the sum of the non-adjacent interior angles. This exterior angle C is the sum of the non-adjacent interior angles. Means we have C is equal to the sum of A and B. Sum of A and B. If I shift C here, I can get A degrees plus B degrees negative C degrees is equal to 0. The sum of A, B and negative C is equal to 0. Sum of A, B and negative C is equal to 0. So we plug in equality symbol here, equality symbol here, equality symbol, equality symbol, equality symbol. From this very tiny fact, exterior angle of a triangle is equal to the sum of non-adjacent interior angles. Exterior angle is equal to the sum of non-adjacent interior angles. That this fact, this tiny fact we have utilized. That tiny fact we have utilized. Our geometry is not going to be accuracy. Moving towards next question, we have in column A, we have column A, we have 10 raised 20, while in column B, we have 20 raised 10. We have 20 raised 10. Now we have to establish a relation whether column A is greater than column B or column B is greater than column A. Either they are equal or there must be exist a comparison whether they are equal, less or greater. One thing is possible. Power is 10, here power is 20. Here power is 10, here power is 20. So I can write this 20 as power 20 can be broken down as 2 times 10. I can write this 20 as 2 times 10. I can write this exponent, this power 20 as 2 times 10. 2 times 10. 2 times 10. Okay. 10 square means 10 times 10 raised 10. 10 times 10, it's 100. 100 raised 10. 100 raised 10. And here in column B, it is 20 raised 10. 20 raised 10. Look at this. Both these have same exponents. Same exponents. we don't worry about them. They are 10, 10. Even we can taking power 1 over 10, they can be cancelled out. Power has been utilized. Powers are same. So all things depend upon which. This is 100, this is 20, and 100 is far greater than 20. 100 is far greater than 20. So column A, that is 10 raised 20, it is far greater than 20 raised 10. 20 raised 10. So column A is greater than column B. We have done nothing. There's 10, there is 20. Look at the beauty. 10 has been present here. 2 times 10. I have utilized this fact. 2 times 10. 10 square can be simplified to 100. 10 square can be simplified to 100. 100 power 10, and here is 20 power 10. Both powers are same. Powers are same. Now we are at safe ground. We are easily conclude that 10 100 is greater than 20. Column A is greater than column B. Column A is greater than column B. Column A is greater than column B. So we insert a symbol here. Column A is greater than column B in that situation. It is my tiny effort to you guys explain to you some good questions about sat and gri. It's my personal correction or the experience of some tiny years. It's all bad.